In this lesson, you will solve quadratic equations by graphing and estimate solutions of quadratic equations by graphing. So first of all, what are zeros? Zeros are the roots, x-intercepts of a quadratic function, and there are four types that you can have. So let me just show you what you might have. You're going to have two roots if you have a parabola that will actually cross in two places on that x-axis. So this would be two solutions that you would put inside fat man brackets. Let's say this is -2 and 3. So you have two solutions or two roots. One root is going to be a type of parabola that literally sits on the x-axis. So for example, it'll look something like this. And so it just has one root, one solution, because it just touches the x-axis in one spot. A no roots is going to be a parabola that's up in the air. What I mean by that is it's going to have a vertex that is maybe in a quadrant, and it's not going to touch the x-axis at all. So this is what we call a no roots or a no solution or empty set. And rational roots are where we would have a parabola, like let's say that this is -1, let's say that this is 2, and this is 1. We have a parabola that actually has roots, but they're in between whole numbers. So we would have to give them decimals or fractions as results. Those are called rational roots because they're not whole numbers, they're fractions. So these are the four types of solutions that you can have today. So let's look at examples of what these are. You start by graphing. This is already set equal to 0, so you're going to actually plug this into your graphing calculator. And as you can see, I'm just going to use Desmos today. So I have that plugged in for you already. So here is that parabola. Now what you're focusing on are these two spots. Here at -2 and here at 4. So inside fat man brackets, you would say -2 and 4. This is an example of a solution where you have two roots. You cross the x-axis in two places. So you graph that parabola using your Desmos or your other graphing calculator, whatever you're choosing to use, and then you would say where the solutions are. So try the example of a two roots in your notes. All right, now we have an example of double root. If you'll look at this equation is not set equal to 0, so we are going to have to add 9 first. So we have x squared minus 6x plus 9 equals 0. So this is what you're going to plug into your graphing calculator. And I used Desmos once again, and this is what I typed in. And if you'll look at my root, here's my x-axis, it touches in one spot. We call that a double root or a one root. So you would put your fat man bracket and you would write 3 because this particular graph crosses at 3 or it touches at 3. So this is a one solution or one root. So you try the example of a double root in your notes. All right, next up we have a no roots. This equation looks ready to graph. It's 2x squared plus 3x plus 5. So we graph it using the graphing calculator, and I use Desmos once again. So I plug that in. And if you will look here, it does not cross the x-axis at all. It is one of those parabolas that's up in space. So what we're going to say is fat man bracket, no solution, fat man bracket. Because there are no roots, it does not cross in any spot. So try the example in your notes. All right, for example 4, this is what we call rational roots. It's set equal to 0, so we can go ahead and graph this. So I plug that into my Desmos, x squared plus 6x plus 6. And here it is. If you'll look here, I am crossing the x-axis in two spots. So I click to see where I am. Let's just go to the nearest 10th. So my first root is at -4.7 approximately. And then my second root, if I click here, is at -1.3. I just rounded to the nearest 10th. These are rational roots because they are not whole numbers, they're decimals. But it does have two roots. So you try the example in your notes. The last thing that you're going to do for this lesson is a real-world example. A soccer goalie kicks a soccer ball with an upward velocity of 65 feet per second, and her feet meet the ball a foot off the ground. So this is the function. We can graph this. I just type this into Desmos, And when I type it in, I'm going to have to zoom out quite a bit because it's a very, very large graph, a very, very large parabola. What we're worried about here is the time. How long is this ball in the air? We don't care about the height. We just care about how long it's in the air. So what we're looking at is the x's here. So this is where that she kicked it at a height off the ground. This is our time right here, our x value where this parabola crosses the x-axis. She kicked it here and it landed here. So this is how long it was in the air. So we would say approximately 4 seconds. So you try the real rule example in your notes and make sure you zoom out on your graph so you can see the whole parabola.